What's up? What's up? Is your man Jimmy Chan. I want to teach a quick math lesson on this beautiful eGlass so that you guys can see what your lecture videos might look like to your students. And then also to show you guys what the PDF might look like after I take a snapshot of the full set of notes. All right. So today what I'm going to be showing is a lesson on simplifying radicals. And there we go. So let's take, for example, that I'm going to take the cube root of 432. And again, this will be an example, right? Great. So from here, what I usually tell my students to do is to break the 432 down to prime numbers. And of course, they're always looking at me weird, going, what do you mean? How do we do that? So I explained to them that it's like back in the day when you were kids and you guys did factor trees. Then they understand factor trees. So we know a prime number 2 goes into 432 216 times. 2 is already a prime, so all we're going to do is just going to keep on bringing it down. 216, 2 goes in 216 108 times. There we go. 2 is a prime, 2 is a prime, 2 goes into 108 54 times. 2 is a prime, 2 is a prime, 2 is a prime, and 2 goes into 54 27 times. 2 is a prime, 2 is a prime, 2 is a prime, 2 is a prime, and I'm going to do a shortcut right here and tell you that 27, in case you didn't know, is 3 times 3 times 3. And there we go. So what we're going to do is take these numbers right here and we're going to go ahead and replace the 432 that's currently up here. So what I can say is, okay, so I have the cube root of 2 times 2 times 2 times 2, because there's 4 2's here, times 3 times 3 times 3. There's 3 3's right here. All right. So great. I have just replaced the 432 with the product of primes. So what do I do next? So what we got to look at is this right here. This is my index. The number inside that wedge is called my index. And that is a 3. What does it mean? How does it help us? Well, 3 means that we're looking for 3 of a kind, okay? Or you can think of it as groups of 3, all right? But it has to be the same thing, all right? So if I look at these numbers, you can see that I have a group of 3 2's and also a group of 3 3's, right? So think of this as on this certain day in grade school, the teacher just happens to be thinking 3, so he or she tells the kids, hey, during recess, what I need you guys to do, if you guys have a group of 3, you guys get to go out to playground and play. Else, you're going to have to go ahead and stay inside the classroom. All right, and you can think of the radical as inside the classroom. All of these guys are right now inside the classroom, and now they get to go out to play if they have groups of 3. So since the 2 right here has a group of 3, they get to come out to play. Let me go ahead and box this so that you know it's coming from that box right there. And the group of 3 also gets out to come out and play. I will also box that one so that you know it's coming from that group of 3. And then who has to stay inside? Well, this lonely 2 has to stay inside, and they don't get to go and play. All right, they get to be stuck inside the classroom teaching a lesson on eGlass. Yay! But anyways, so the question is, what do we do with the 2 and the 3 in front or outside the classroom? We actually go ahead and multiply these 2. So we're going to get a 6 cube root of 2. and that would be the correct answer. Now, the question is there a way to check this? Absolutely. If you put in the cube root of 432 into the calculator, you'll get a decimal. And then keep your eye on that decimal, and then plug in 6 times 2 cube root of 6 times the cube root of 2, and see if you get the same exact decimal as this. If you do, guess what? You have the correct answer, and you definitely simplify the radicals correctly. Well, I hope this helps, and I hope that you have a wonderful, blessed day. Love you guys. I'll talk to you soon. Later. Bye.